My name is Rotational. We're doing the 2019 FRQ question number 5. So first and foremost, this question is an area between curves / volume question. So for this one, we were told that it could be cross-sectional or rotational, as well as that when it was rotational, it could be disc or washer for the volume, and then just to look for whatever slice works best. So to start with, this first question is area between curves question. So I'm just gonna do the h of x, this one, minus g of x to get my slice, and then times d of x, the width of the slice, and then the integral to get the sum from 0 to 2. So I plug that in, 6 minus 2, x minus 1 squared, and then g of x, which we are told in the problem. And then I simplify that, and then I use the first rule of integral calculus to do antiderivative from 0 to 2. And so then that gives me, and so then I simplify that by plugging in 2 to it, and then subtracting by the same equation just with 0 plugged in. And so then I get 16 minus 2/3 minus 2/3, simplify that to 44/3. So B, so for this one, I didn't really use any tips because we didn't really have any tips on area between curves. It's just that they'll be there. B is cross-sectional volume right here. And so we are given the area of the slice, which means that I don't have to find the area of the slice. I just plug it into the integral. So integral from 0 to 2 of area of the slice times dx. Again, area of the slice, and then dx for the width, and then from 0 to 2. So then, once again, I'm going to use first rule of integral calculus, plug it in use antiderivative from 0 to 2, plug in 2, minus plug in 0, I get ln 5 minus ln 3, simplify that to ln 5/3. And for this, I also didn't really use any tips because we didn't really have any tips on cross-sectional volume. But then this third one is rotational volume, so they want it rotated about the line y equals 6. And so I drew that y equals 6 up here on my graph, and it's rotating about that. So for this one, I did use the tips because you mentioned that the AP doesn't really require any specific type, so you just draw the slice and you figure out, and just based on what would be best for the problem, and then you solve from there. So that's what I did. So I decided to do a vertical slice because I knew that if it was a horizontal slice, it would be between different lines at different points, which just makes life difficult. So instead, I did a vertical line. And so that means that I'm doing the washer method because the line is not touching my axis of rotation. And so then I'm just plugging that in, v equals pi, and then integral from 0 to 2, and then 6 minus g of x, because that gives me just this, 6 minus g of x gives me this distance, and then 6 minus h of x gives me this distance. So then when I subtract them, I get the distance in between. But then r is supposed to be squared, so 6 minus g of x squared minus 6 minus h of x squared, and then once again dx for width, and then from integral from 0 to 2. And then I don't have to solve it, I just have to write it, so that is it.